Hello everybody and welcome back to Business Statistics Online at Frederick Community College. In this video, I will show you how to use Excel to find probabilities for problems associated with normal distribution. So before we get into the mechanics of computing these probabilities, let's just review real quick the really basic information about normal distribution. So normal distribution refers to the data that's shaped like this. We have a bell-shaped curve, and we have the mean of this distribution sitting right in the middle, and the notation is mu, that is your mean. Okay, and in this case, it's also the mode and the median, and the notation for normal is n, that has two parameters, mean and the standard deviation. And if you remember, we've covered this information before. We had an empirical rule that said, okay, we have 68% of the data that lives within one standard deviation of the mean, so one above and one below. And then we have 95% of the data within two standard deviations, and then almost all of it within three, right? 99.7 within three standard deviations. We also said that the total area under the curve is 1, and that represents the total probability or 100% of the observations, right? So if I were to compute this area right here, or both of my branches go to positive infinity and negative infinity, I would get exactly 1. Okay, so now let's go ahead and take a look at some examples and see how we need to use Excel to compute probabilities. All right, we have the following setup here. We have some questions that ask us to shade the area and then compute the area under each curve. Okay, and we're going to use Excel for this. And let's go ahead and start the one in the middle. So we would like to shade the area to the left of z is equal to negative 0.35. And then we'll want to find the area. So let's see what we're dealing here with. We're actually dealing with standard normal distribution, where standard normal has two parameters. Mean is 0 and standard deviation is 1. Okay, so these are the parameters that will not change for standard normal. So how would we answer these questions? Let's go ahead and mark our value on the graph, and then we'll shade it and see what Excel command is needed to compute this. So to the left of z is negative 0.35. So this value right here would be right around here, right? So that is your z score, negative 0.35. Okay, so that means I need to find the area over here to the left of the z-score, and I can take a look at it and say, okay, well, it's going to be definitely smaller than 1/2 because this piece is smaller than exactly half of the distribution. So how do I do that? Let's go to Excel, and we're going to do the following. We're going to say equal norm distribution, and the syntax goes like this. We go up to the value that we would like to compute. So in our case, it's negative 0.35, comma. The mean is 0, comma. Standard deviation is 1. And then cumulative, this is asking, do you want to add up all of the probabilities from negative infinity up to the value that you are asking? And the answer here is yes. So for normal, we will actually always say yes. So you can either say true or you can say 1. Okay. So now we get 0.3632, right? So that's what's going to go here, 0.3632, and you should always use a common sense check. Does that make sense? Yes. Okay, it looks like roughly under 1/2, right? So this piece right here represents the other part of 1/2, so 0.137, right? So that would be this piece right here. okay? But we know that this and this should add up to 1/2. So this definitely makes sense. But let me go back to this command right here. What is this command doing? It's computing the area under the curve from negative infinity up to this value right here that you highlight, okay? So that's what it's doing, all right? So from negative infinity, from all the way here to up to the value that we specify, okay? Let's take a look at the next example. This one says, shade the area to the right of z 1.2. So where's 1.2? So let's say roughly right here. And we would like to find the area to the right of this, right? So this piece right here. Okay. Now, if you were to plug in exactly the same command, well, I'll just go ahead and do it, as we've done for the previous problem. So let's say normal distribution. We go up to 1.2, 0, 1, and true, you can just type in 1 if you would like. Well, you're getting the area to the left of this, okay? So this piece right here, that's what you've computed if you were to plug in straightforward. So it's always a good idea to just use common sense to check your answers, okay? This area right here is 0.88, right? 0.885. So how would you compute this one? Well, the total area is 1, so you would do 1 minus that, and that's how you would deal with questions that say what is the area to the right of the z-score. So I'm just going to plug in 1 minus in here, and there you go, 0.1151. That's my answer, and again, 0.1151, right? So let me write it out here. That makes sense because this piece right here should not be 0.885, right? It should be smaller. So that's how we approach these type of problems, okay? Now let's take a look at the next one. This one says between negative 1.4 and 2.1. Let's go ahead and mark our values. So negative 1.4 is roughly here, and 2.1 is over here. Okay. This is the area that we would like to find. Okay. How do we do this one? Well, first, let's just think about it. What should we get? Well, we should definitely get more than 1/2. In fact, we should get a lot more than 1/2. So the only thing that we're missing here is this piece right here and just a tiny little piece here, right? So I'm going to go ahead and estimate that roughly 90%, maybe a little less. But how would we actually compute this one? So here we have to think critically just a little bit. If we were to compute from negative infinity to the lower limit, then we would get this piece right here, the purple, right? And then if we were to compute from negative infinity to 2.1, then we would get this piece right here. But that's not what we want. We want to get the piece that's right in the middle here, highlighted with green. So we're going to compute both of them and then subtract the smaller from the bigger. You know, if you think about this as puzzle pieces, that's exactly what we need to do. Okay, so what I'm going to do here is the following. I'm going to say, okay, first I'm going to find the probability or the area under the curve up to 2.1. 2.1, 0, 1, true, and then subtract the area under the curve up to negative 1.4. So normal distribution, negative 1.4, mean is 0, standard deviation is 1, still cumulative, and that's my answer. 0.9014. Okay, 0.9014. There you go. And that makes sense because that was actually a pretty good estimate, right? So that's how you would deal with probabilities or areas under the curve where you have these two numbers as your limits, okay? All right, let's take a look at the next example before we do an application problem. This one says, find the z-scores for which the area to its left, the area to its right, and the middle area is a given percentage, okay? So here we're actually going to use a different command. We're going to be using inverse normal or normal inverse. So this inverse, think about it, is it's returning the z-scores. Z-scores or percentiles, okay? So, we're going to find the z-scores that cut our distribution in certain percentages. Let's take a look at the first one. This one says, find the z-score for which the area to its left is 0.35. Okay? If the area to its left is 0.35, well, I'm going to just go ahead and make a guess. It's somewhere right here. Okay? Because the area to the left of this score should be less than 1/2, right? Well, it might be even a little smaller, but okay. The picture itself is not important. We need to make sure that we set this up correctly. Okay, let's go ahead and do this one. So z-score, the area to its left, is 0.35. How would I do this? Okay. We're going to do norm inverse. That's what I and V stand for. Open the parentheses. And here you're going to plug in the following. Probability to the left. This has to be the area to the left of your score. So in our case, it's 0.35. Mean and standard deviation. In our case, we're still dealing with standard normal. 0, 1. We get negative 0.38532. Does that make sense? Negative 0.385. And what was the other numbers? 32. The answer is yes, it does make sense. Okay? Because it's to the left of 0. The value here is negative. One way to check this, how would I check this? Let's go ahead and check. Okay? If I were to do normal distribution and I go up to negative 0.38532, mean is 0, standard deviation is 1, cumulative, yes. If I've done this correctly, I should get 0.35, and I do. Okay, so that's one way for you to check if you've done this computation correctly. Okay, let's take a look at the next example. The area to its right, it's 0.42. Now this one is not exactly the same as before. Now it says the area to its right is 0.42, which means my z-score is somewhere to the right of 0, so somewhere right here. Okay? This is the z-score that I need to find. It needs to be positive. I know for sure because this area is 0.42. Now this area is 0.42, but that's not what I will be plugging into my Excel command. I will be plugging the area to its left, and that's just how the command is set up. So if this is 0.42, then this one is 0.58. That's what I need to plug in. So let's go ahead and do that. The area to its right is 0.42. Okay, I'm just going to copy this down here, and I'm going to change just one parameter. I need to plug in 0.58 into my command here, and the z-score that I get is 0.2019. Okay, so that is my answer here, 0.2019. That makes sense because it's to the right of 0. It's positive, so I'm happy. Okay, of course you can always check. You can check what if you've done this correctly. So 0.201893, then you get 0.58, which is the complement of 0.42, right? Okay. Let's take a look at the next one. This one says, find the z-scores that bound the middle 75% of the area. Okay, so somewhere here, set my middle 75% of the area. Okay, these scores are completely symmetric. Okay, and you can think about it this way. We know that 68% of the data live within one standard deviation of the mean, right? Which means 75, the z-score should be a little bit bigger than 1, okay? Because 75% is greater than 78. I know my values should be right around here. They will be probably close to 1, but not too far off, okay? So how would I approach this problem? I need to find these z-scores. But what's going to happen here? I need to find the area to the left of this z-score right here. Well, what is it? This area is 100% minus 75% divided by 2, right? Okay, because this area is exactly the same as the one to the right of this score. So 100 minus 75, that's 25%, divide by 2, so we get 12.5, right? So what we're going to be plugging in into our command, we're going to be plugging 0.125 as the area to the left of our negative z-score. So let's go ahead and do that. Okay, so I'm just going to copy this down, drag it down, and plug in 0.125. Press enter. So I get negative 1.15. Let's just call it that. Okay, so what are my z-scores? My z-scores, there's 2 of them. Positive and negative 1.15. Okay, these are the z-scores that bound on the middle 75% of the data. All right, okay, I'm gonna go ahead and stop right here, and then we'll make a different video for an application because this one is already almost 18 minutes. But thank you for watching. I hope this was very helpful.